Thank you very much, and thank you for that intro. Wow, what an amazing room. This is one of the nicest rooms I've ever presented in, so this is a great privilege for me to be here in this room. Thank you for coming to this session. And yeah, as the title suggests, we are going to be doing a lot of live hacking today. We will be both looking at some of the vulnerabilities that exist in real projects, real applications, real libraries, and we will try and exploit them. Well, I say we. You're going to try and exploit them, and I'm going to just type at the keyboard. So this will be an interactive session for some of the exploits. A little bit about myself before we get started. There we go. So who's heard of the Virtual Jug? Virtual Java User Group is a completely online Java user group that I founded maybe 4 or 5 years ago. It's still running strong. Oleg Shalaev, who's here as well, does a huge amount for the Virtual Jug. I also co-run the London Java User Group, so I'm very, very strong into my kind of community. I've been a Java champion for around 5 years or so, and I'm a developer advocate at SNCC. And this is one of the reasons why I'm giving a security talk today, because SNCC is a company that provides security tooling. I will show a little bit of SNCC today, but it's going to be entirely the free tier of SNCC. I'm not going to show you anything that costs any money. And we're going to focus on the live hacks. So, I'm going to start off with a term called DevSecOps. Who's heard of DevSecOps before? A few, not too many. Okay, so DevSecOps, the concept of DevSecOps is about pulling security into your DevOps pipeline, pulling security into that pipeline so that you are testing as you push to production. Okay, I've come straight forward with a solution. The solution is DevSecOps, very much like blockchain. It's a solution, but unlike blockchain, DevSecOps have some problems that it's trying to solve. Now, we're talking about the fact that DevOps has sped up the pipeline, right? We can deliver, how many people deliver software into their production environment once a week or less? More than once a week. Quite a few people, right? I mean, when I was working back in the day as a developer in IBM, we used to have releases every 2 to 3 years, right? Life isn't like that anymore. Life is like the fact that we want to make small changes and push them to production very quickly along a pipeline that we can predict. And adding security into that pipeline allows us to make sure that our changes are not regressing any security issues that we're putting in. So adding that security focus throughout in design, in development, in CI, in our repo, and then pushing into production is what we're trying to solve here. One of the other issues, and this has obviously come up in DevOps as well, is the segmented kind of operations that we have, or segmented teams that we have between developers and operations for DevOps, and with security, we have developers, operations, and security, and you know, it's very traditional for security teams to very often audit perhaps every release, or every major release, or every 3 months, every 6 months, every year perhaps, and that doesn't fit in with the modern development pipelines that we have today. So pulling in that expertise into the development teams so that we can, as we design, as we create our software, we're getting security insights. And as developers do find vulnerabilities, they have the capacity to talk to the security team and ask about what the impact of those vulnerabilities are, whether those are exploitable in our applications, and what the damage could be. And of course, there's this thing about customer data which we don't want to compromise, and never has the headline been bigger, really, in the security space, as the Equifax breach. Who's heard of Equifax? Keep your hand up if you heard of Equifax before the breach. Right, virtually everyone put their hands down. There's a few up. And you know, these are the kind of headlines we don't want our companies to be in. But I don't want to necessarily talk too much about the company. I want to talk about what happened behind the scenes. And what happened behind the scenes was there was a Java Struts vulnerability. And that Java Struts vulnerability was exploited just a couple of days after that vulnerability was disclosed. And guess what? There are exploits that are made available on the web very, very easily for people to find. And these exploits, anyone can just grab, run against a Struts endpoint, and actually have some exploitable code. One thing that I will say here is you can see the massive peak of attacks on and this is not Equifax specific, a massive peak of attacks on Java Struts libraries. Okay, so one of the key things here is when you have a vulnerability in your open source code, because of the amazing reuse that we have in open source these days, one vulnerability can lead to many different exposures in many different sites around the web that use that library. So what we're going to do now is we're going to go terminal, and we're going to show you that application, an application running, and we're going to show you that application being exploited. So This is an application running, which I can show you is running on Heroku. So this is running live on the Heroku cloud. If I sign up, there we go. I'm going to sign up. Let's sign up with my email, snick.io. I'll use 1 to 6 as my password because I work for a security company, so that's what we do. There we go. We have our to-do list. I can create some to-dos. I can say, let's buy my wife some flowers sometime in 1970. So I'll make that high. There we go. We can see a to-do list. It's a regular to-do list. It uses, if I click on the About page, we can see it uses Struts 2 at a vulnerable version. We also use an very early version of Spring, and we use Hibernate because I love to make bad life choices. So this is what I'm doing. Now what I'm going to do is I'm going to attack it. So I'm going to come here. I have, if I find my Struts exploit headers, I'm going to cat that, and this is the header that I need to send on any endpoint which is vulnerable to this vulnerability, and I just send this. That's all I need to do. Any request with this header will actually go through a vulnerable path, and an exploit can happen. Let me take you through it. Here we have a content type. Anyone recognize that content type? You shouldn't do, because it is an illegal content type. As a result, we will go through an exception path. Through that exception path, we are able to actually run executable code. And this is also because of the OGNL library, which allows us to run executable code. And you'll see this more and more, that as and when we get that chance to run executable code, what we typically do in Java particularly is run a process builder. So now we're going to instantiate a new process builder, and there we can run whatever we want. Here I'm just going to run commands, which is actually executing a new bash window, passing in a command of my choice, and this is just going to be a placeholder here with command. I can send this now to a strut endpoint, and as a result get some exploits. So let me show you that now. If I quickly cat this and grab one of this will save my typos. Okay, so I'm going to cat this struts exploit headers, the one I just showed you. I'm going to substitute env to grab my environment variables from that instance, and rather than attack my local host, let's attack that Heroku application, which is this. There we go. Right, I'm going to attack that Heroku application, passing in that header. As soon as I execute that, bang, we've got the environment variables of that Heroku machine. Right? Who stores passwords, keys, usernames in your environment variables? No one. No one. Put your hands down. Come on. We're all amazing developers. That's why we're here at Devoxx Poland. But one of the things that when we get access to your environment is we can learn. And as an attacker, from a red team point of view, we learn about your environment. We get knowledge about what's running, what are the usernames, passwords. What can I execute? Can I install malware? Can I get some IP traces? What can I learn about your environment? And if we take that Equifax example, attackers were in Equifax for 1 to 2 months, 6 to 8 weeks before the breach happened. So the first hack on Apache Struts happened. They were learning, gathering knowledge, understanding better ways in, somewhere with greater privileges that has access to databases and so forth, and then the breach occurred. Okay? Equifax, as it happens, didn't actually know for another month that they were breached until that's when they went public with it. But there were a number of problems that they had, which they are doing amazingly well now to close out. So, let's continue. Going terminal, so there we go. So, your application. When we think about your application, it's split into 2 pieces. The piece that you write, the piece that's in your IDE that you change code and check code in. And then the bigger bit, which is the bit that you pull in, your dependencies, the open source code, the libraries that you are making use out of. Now, this is great. This is a great picture because you can write a small amount of code and you can use libraries, use frameworks that'll do things for you. We don't want to rewrite the wheel every single time. However, when we think about where vulnerabilities are going to exist, not only is there a greater chance of them existing in this yellow section because it is a greater area, but also there are databases full of vulnerabilities, known vulnerabilities that exist in the libraries in this yellow section. So let's take an example. Any Node developers in here? Primarily Node developers, JavaScript developers. 1, 2. Right, I will be making jokes at your expense throughout this session, so I am sorry. 19 lines of code. Did that almost get a round of applause? Sorry. 19 lines of code in this application. This application is going to be, is just going to grab a file and it's going to store it in Amazon's S3. Only 19 lines of code. Amazing that 19 lines of code can do that. How many direct dependencies do you think this has? Just shout out. 100,000 was that? Any reasonable guesses? Given that this is only 19 lines of code, it can only have a maximum of 19 dependencies. 2? I think someone said 2. Yes, you can actually see it at the top there, Constant Fetch and AWS. So we have 2 direct dependencies. How many transitive dependencies, indirect dependencies, do we think this has? And I know this is going through NPM, but it's not as bad as most NPM node applications. What do we think? 200. No, not quite as bad as that. 60. Only 19. Okay, so this is actually a reasonable ratio. For every one dependency, we get around another 9, 10 or so. How many lines of code do you think we are deploying in this whole application? 10,000. Any increase on 10,000? How many? 192,000. Have you seen this before, sir? And you're still wrong. 191 lines of code. So you didn't concentrate last time. 191,000 lines of code. And that's spectacular, right? 19 lines of code that we write, and we think, I've got a really small application, but what we're deploying, what we're maintaining, what we're supporting, what we need to, these 200,000 lines of code, that is what needs to be bulletproof for our sensitive customer data to be secure. So when we think about what we need to make sure the quality is good on, make sure we secure, it's everything. Our code as well as the dependencies we pull in. So attackers, as a result, are targeting open source because one vulnerability, a single vulnerability, can have many different paths in your application and many different applications across the web that use it. If there's a vulnerability in Struts, guess what? Most Struts users are going to be affected. That's a huge number of people a potential attacker can target. Of course, we're not saying open source is bad here. Open source is amazing. We know that. And it's unavoidable if we want to get ahead in our development. But we must understand how to use open source securely and safely. Okay, so let's have a look at the growth in packages which are indexed in a number of different repositories here. We can see that in the last year, from 2018 to 2019, over 250,000 new packages were indexed into NPM. Amazing, astounding. 103% growth on Maven Central. Okay? Actually, very recently, NPM hit the 1 million mark on a number of packages indexed. And I spoke to someone on Twitter who basically said he thinks it was him. And I said, how did you think it was you? And he said, well, I was tracking up until 999960, and then I wrote a script that uploaded 40 packages. And it's like, okay, I guess it probably is you, and I can probably guarantee you that those probably aren't the worst 40 packages in NPM either. Now, let's think about where our vulnerabilities come from in our application. We're looking at the majority, actually, in our indirect dependencies. If we look at NPM, Maven Central here, the vast majority of vulnerabilities that exist are in our transitive dependencies. So it's not even the direct dependencies that we pull out. Very interesting. When we think about some of the vulnerability types and how they grow year by year, we can see that the number of cross-site scripting vulnerabilities are on the increase. How can this be? We all know what cross-site scripting vulnerabilities are. We know how to defend against them. But not everyone who is pushing their code up it cares about it or recognizes where their code is going to be used. So we can see more disclosures than ever in cross-site scripting. Path traversal, similarly, the idea of a public directory that you are trying to provide, serve data, serve content from, that public directory is where you want people to stay in. But if an attacker can traverse outside of that public directory, they have performed a path traversal or a directory traversal. This has been cracked down on NPM quite significantly. When you see massive spikes like this, in a specific repository or registry, it's typically because the working groups have focused on finding those types of vulnerabilities in their ecosystem. And a regular expression denial of service, again, something else which is on the rise. Who loves regular expressions? Yeah, the odd few. You're the trouble people that we all have, right? Who likes reading other people's regular expressions? I don't believe you, sir. I don't believe you. Okay, so regular expression denial of service. The idea of a regular expression taking so long to compute that it causes a denial of service. Very, very dangerous on an NPM, a Node application or a JavaScript application because of the single-threaded nature of the application. So, enough speaking, enough slides. What am I doing for time? Not too bad. Okay, let's jump into some hacks. Okay, I've got a Goof application here. This is a Node application because it's more fun to hack Node applications, I find. I can write some things. I can write, let's buy some milk. I can do something like, let's buy some beer. But beer is more important, so let's do that, and we get it in bold. So now we can see we have Markdown support. So we have Markdown support, and we have a regular to-do. I also have an about page, a very modest about page, which is being served here from the public directory. Okay? Now what I'm going to do is, and as I mentioned, everything I'm showing you is entirely free to use. I'm going to log in, and I logged in just via my credentials for GitHub, and I'm going to scan this project. And from that scan, we can see which vulnerabilities we are going to find in my application. So there's the Goof application. I scan that, and what that's going to do is it's going to look for my manifest file, because the manifest file is all we need in order to understand which direct dependencies and which transitive dependencies exist. Put your hands up if you know how many direct dependencies your application has. 1, 2, 3, 4. Right. Not many. Keep your hands up if you know how many indirect dependencies. One gentleman. Out of a fairly reasonably full room, only one person has their hand up, right? And this is one of the other talks for this is called, one of the other titles for this is Stranger Danger, okay? And it's about who do you trust? Because we're pulling in source code and compiled code from strangers, complete strangers we've never met, we don't know who they are, and we're running that on our application. We're running that in our servers, okay? But we don't know who they are. We don't know whether they should be respected or whatever. So if I view that log, that's already been imported, by the way. We can see the package JSON has been found, and from here, I can work out exactly what my dependencies, which dependencies I have. I can see my direct dependencies and my transitive dependencies, and which ones have vulnerabilities and what severity those vulnerabilities are. Okay? Right, let's start hacking. Down here, right near the bottom, I think, over here, there is a package called ST. Now, ST, here we go. ST is a package that serves static content, okay? And there's a directory traversal vulnerability found in this package that serves static content. So, what are we going to do? How can we hack this environment? Let's go back to this application. We know, where's it gone? Here. We know this application has a directory traversal. We know it's serving static content because it's using ST, and that's where the directory traversal is. How are we going to break this? Where do we need to go, first of all, to break this? Say again? Not the source code. And what was that injection through marked? Markdown. That is. We'll do that one next, sir. There's another vulnerability there. Any other ideas? The URL. Which URL? The about. Very good. Okay, here's our URL. Who wants to be a proper hacker? Should we do this in the terminal or should we do this in the URL? Oh, come on. Let's do it in the terminal. Right. If I had a cap now, I'd put it on backwards and dim the lights, and it'll be like a movie. Right, there's our About page. You can see it's a massively durable application. The About page looks just as amazing in a terminal as it does my browser. How are we going to hack this now? How are we going to traverse? Change About to ... Something like this. Hands up if you think that's going to work. It's classic directory traversal. No one, not even the person who suggested it. Excellent. Right. We run that, bang, we get something different, but what is it? Beer? This is the homepage. Okay? And it's a homepage because ST is a real library. It understands directory traversal, and it recognizes that the dots exist. And because the dots exist, it knows we're trying to do a directory traversal because of these two dots. So what else can we do? We're on the right lines. URL encoding? Who said that? You, gentleman here. Do you know the URL encoding of a dot? Anyone else? URL encoding of a dot. %20 is a space, and I'm not taking answers from Brian because he works for SNCC and gives this presentation as well. %2 something, 2E, there we go, %2E. You can tell the hackers in the room. %2E, who thinks this is going to work? Not even Brian, who gives this presentation, amazing. There we go, bang, we get to outside of our public directory. We know this because we can see the public directory. We have performed the directory traversal. Okay, what do we do now? Put your red team hat on now. As an attacker, what would you do? Repeat. How long for? Until we get to the root. What's the cd dot in the root is the root. So I can do that as many times as I want. Root. Anything else? Passwords, my etc passwords. Wow, why do you want to see my password file? What's wrong? I thought we were friends. There we go, etc password file. There's not much in here because actually this is running in a Docker instance, so that's what I don't really care. I can show you that. This is running on a Docker instance on this machine. So yeah, this is the etc password of the Docker file. Anything else you want to see? How? Configuration? Maybe the configuration of the app. What do we have? We have app.js as our application. What about package.json? Oh look, all the other direct vulnerability, all the other direct dependencies we have. We can work out at these versions which have transitives, which have vulnerabilities in either direct or transitives. Okay, so this is only a medium sev vulnerability, and it's medium sev because we can't change anything. I can't execute anything. But what I can do is I can actually start looking around the system, and that's very powerful because looking around the system, I can find alternate ways to get in, alternate permissions that will allow me to maybe find different things. So this is a great way of learning about the system. Any questions? Okay. Next one I want to show you. Let's do the. Let's go back to Java. Let's go back to Java, and I will show you. Actually, I'll show you one called ZipSlip, which is a fun one. ZipSlip is the idea. In fact, if I was to go back to this hack that we did just a moment ago, this was the Apache Struts hack on that application, which exists in Heroku. If we look there, we can see halfway down. Java home is /app/.jdk. We now know the location of our JDK. One other thing I know about this application is that it allows me to upload some files so that I can upload or I can import a to-do list. And that will then nicely be extracted by this application, and that will then nicely update my to-do list. However, the to-do list I'm going to pass it is called zipslip.zip. And if I was to jar -tvf so you can see this, let me do that at the top so you can see that. I have two files. I have a good.txt, and I have going all the way back to the root into the .app.jdk, and I'm overwriting the native to ASCII file which exists in the bin directory. Okay, what is the native to ASCII file? Let's have a look. It just echoes, mwahaha, gotcha. Right? Now, what this to-do application does is, for every single to-do that gets created, it's going to turn, if there are native characters, it's going to turn it into an ASCII representation. So it calls the native to ASCII command for every single file. So if I was to upload this zipslip.zip file, is this bottom one? No. This one. If I was to upload that, hopefully, we only get the good.txt. So one of two things has happened. Either that directory traversal has been caught and it has been stopped, or I have gone all the way back and overwritten my native to ASCII file. So let's take a look by just creating a to-do. Let's buy some more flowers. Let's still do it in 1970. And make it high. Create. Bang. Okay? We have overwritten a file, and it's worse than that because this is a file that can be executed. So we have an arbitrary code execution. Okay? And this is typically because we don't validate our input. Anything we do in our applications, we need to validate our input. Let me show you an example of input validation. I think I've got it down here. in this case, actually, the file that was the executable that was used, which I'm sure many of you will use, is the zero turnaround zip util. Okay, allows us to unzip an archive because we can't do that in native Java. We don't have the opportunity to do that. Let me show you what some people do in their application. What some people do, if I was to let me uncomment this, or comment that and uncomment this. What a lot of people will do, and this will be common for some people, they effectively have a destination directory and a zip file that they want to unzip. They go through every single one, concatenate a new file with the destination and the path name in that zip file, and then create that file. But we do no validation. When we concatenate that, what's going to actually happen is we're going to do the directory traversal, and it's going to be whatever directory we want. And what we actually need to do is something like this: create a canonical destination path, and that canonical destination path, as well as the path of the jar file that we use, the input that we're going to use. When we do a canonical path of that, once concatenated, does that still start with the target directory I want? If it does, then we know this file is going to land in our target directory, so we know there is going to be no path traversal. Okay, but this is the kind of input validation that we don't necessarily see. Okay, for the gentleman who loves reading other people's regular expressions, let's do a redos. Now, what is a redos? A redos is a regular expression denial of service. It's this one. This is the one we're going to attack. And it's in a vulnerable module called MS. And what this does is it takes a string, it parses a string, and tries to see if there is a time unit in that string. So, for example, if I was to say, in fact, let me give you an example of that. If I was to come back here, and I was to type MS1, this is going to give me some text which I can copy. We are going to call mom in 20 minutes, and as I am not American, I'm going to fix that. Call mum in 20 minutes. I'm going to hit that against our local host. I run that. The in 20 minutes is now going to be parsed. This piece here is going to be parsed by the MS library. If I come back here and see what's happened, we can see it's been parsed, it's been turned into a number of milliseconds, and just to present it here, we've put it in square brackets. So we know that representation has been matched, pattern matched by our regular expression engine. So let's talk a little bit about regular expressions. We know, if I was to provide you with a regular expression like that, we know that's going to match. And we know it's going to match. We don't know how it's going to match. It might match by the plus. It might match by the star. We don't know. We don't care. We need to know the Boolean. Does it match or does it not match? Now, if I was to provide a string that doesn't match, at this point, the regular expression engine will try every single permutation of those A's with the plus and the star to see if there is a way it can possibly match. And it will go through all of them. It does it in a backtracking algorithm. Now, as this gets bigger, the time it takes will exponentially grow until such time where we get something called catastrophic backtracking. And catastrophic backtracking is what we're going to try to achieve in order to cause the denial of service. So let's type MS2. And now what we're going to do is we're going to buy milk, and we're going to buy it, and I'm going to increase the number here. We're going to print 5, the character 5, 600, 6,000, 60,000 times. So we're going to do that in 60,005 minutes. That is a long time. If I hit return, we see it comes back instantly. And it comes back instantly because it matches. If I refresh, we're going to buy milk in infinity days. Amazing. That's a great to-do item. Why does it not cause us the denial of service? Any ideas? It doesn't create the denial of service because it matches. It matches first time, and as a result, it doesn't need to try and find another match. So if we was to turn this into something that doesn't match, at this point now we're going to backtrack because it's going to try and work out if there is another alternative method with all these 50,000, 60,000 fives to work out if there is a way. Of course there won't be a way, so if I hit that, we are now in a denial of service. So if I type hello in here, denial of service, single-threaded, until such time, damn. There we go. I've done that once in the last year. Absolutely spot on. I've never been able to do it since. Until such time as that request completes, or the perhaps times out, or perhaps the regular expression engine does go through all permutations. But that's what causes us a regular expression denial of service. Okay, let's jump to Spring. Let's jump to Spring quickly. Who uses Spring here? Of course, pretty much everyone. Who uses Spring Data? A good handful. Who uses Spring Data REST? Right, here we go. 10, 20 people. Who's heard of Spring Break and not the American thing? No one. No one ever hears about this Spring Break. Spring Break is a remote code execution that is just as damaging as this Apache Struts vulnerability that I showed you before. What I have, in fact, I might even have the code here locally. Spring Goof, here we go. What I have is a Spring Boot application. Okay, this Spring Boot application is a grocery list. So I'm going to save some things in my repository because I'm using Spring Data. So I have a nice repository that I'm going to store some grocery items. I can see my item just pretty much has a name and a cost associated with it. And I have this item repository, and this item repository is what's going to be storing my domain objects. Now, the key thing here is this repository REST resource, and this allows us to have access to the data, the domain, where all my data is going to be stored, simply via RESTful interface. So if I come back here and I go over here, I can see in my HAL browser, I can see items, and in our items, I can see we've got beans at 50p, milk at whatever. I can even, because we're obviously looking at this from a JSON point of view, I can do whatever JSON traversal I want as well. So this is my application, and we can see that we have a RESTful endpoint there. What I'm now going to do is come over here and say, let's try and exploit using a piece of JSON. So if I was to cat this, you can see very similar to before. This time what we're doing is we're going to get the runtime. The runtime, we're going to do a simple runtime exec and then send that back to the terminal. Now, what we're doing here is we're very similarly with the Apache Struts exploit, we're using something called the SPEL, the Spring Expression Language, which is used for a richer query language into things like Spring Data. So what I'm going to do now, I'm going to use that header, and if I cat this, I'm going to just simply run a curl. I'm going to run that curl. It's going to send that, and this time I'm going to cat my etc password. I'm going to get the output stream, send that back, and I'm going to hit this against an endpoint, which again, this is just that single RESTful endpoint. I run that. Bang, I've got my remote code execution. My remote code execution is a cat, so that is what I'm executing. It's different from the directory traversal, where we're just doing an HTTP GET. I'm executing cat in this case, and now I can get that data back. Very, very easy to fix. How do we start fixing these? Well, let's go back and actually have a look at how we fix these. Typically, what we do to fix these is simply upgrade the libraries that we're using. Okay? The difference between some OS vulnerabilities versus app vulnerabilities are app vulnerabilities typically have fixed versions. Sometimes it can get a little bit complex when you have the dependency tree, the dependency graph, because if I have a transitive dependency 3 levels deep, what do I need to do? I need to fix my direct dependency to pull in a transitive that is non-vulnerable. And I need there to be a direct dependency that does, a version that does pull in that. So what we need to do is, here we have a remediation. And because I imported this through GitHub, I can actually fix this vulnerability. And what this is going to do for me is fix the vulnerability in GitHub. So if I scroll down, click open a fix PR, it's going to send me that fix PR. And this is very easy to do, particularly when you want to upgrade a minor version, because of course there are going to be fewer issues in terms of our code integrating with an API. If I show you down here, we've done that simple upgrade from 101 and 102. It will be exactly the same for a Maven POM. Okay. How am I doing for time? 15 minutes. Excellent. Let me show you another hack. Who uses Jackson? Yeah, again, everyone. Well, pretty much everyone who uses Spring as well, right? Who's heard of a deserialization of untrusted data? Few people. These are some of the nasty ones if you're exploitable through that. Let me show you a deserialization of untrusted data. Whoops. Okay. This one. Right, deserialization of untrusted data. This is, we know what serialization is. We're pretty much all Java developers here. Marshalling, unmarshalling things. Now, one of the biggest problems here is when we deal with flat data and we're trying to turn this into an object, there are methods that can be called before we can actually do anything in code. And these methods are things like readObject, which provide the JDK with the ability to construct that object if we choose to overwrite it. However, what happens if we put malicious code in those kind of methods that then get executed before we can even do anything? Okay, because we haven't had the chance to even come back in our code to work out what type of class it is. The deserialization of untrusted data, I think Jackson has about 16 of these vulnerabilities, and these are high SEV vulnerabilities. This is the CVSS score, which is a third-party rating mechanism, which allows you to rate how severe vulnerabilities are. And they have a number of different aspects in which you need to say, can I change code on this machine? Can I execute on this machine? Can I run this exploit over a network? And once you've given those answers, it will provide you with a CVSS score, and that will determine how severe the error is. It's out of 10, so this is one of the highest SEV vulnerabilities there is. And what we're going to do is we're going to send a Spring Bean, effectively. This is actually running on, the exploit we're going to do is running on AWS. It's a Spring Cloud function, and it's going to be running in our AWS environment in the Lambda platform. Now, what we're going to do is we are, again, going to create a process builder. And as part of that construction of the object, we are going to, again, run bash, and we can put whatever we want in that command. And given we have the permissions of that process that is running it, we will be allowed to do whatever that process will allow us to do. So let me give you an example. Here I have an ngrok. And an ngrok is effectively a tunneling piece of software that will allow, if someone wants to send something to this ngrok URL, it will pass it right down back to my machine. And this is what I'm going to use. This is the endpoint I'm going to use from within my Lambda to then send data from that machine back to my machine. The command I'm going to run. This is my endpoint. It's an import endpoint. Again, this is a to-do list application. I'm going to call. Let me find. Here it is. This import to-dos function. I'm going to call this endpoint, which is running on AWS, and all this is going to do is it's going to read in a value, and it's expecting a import to-do class. Of course, we're sending it a process builder, but by the time we realize that this is a process builder, it's going to be too late because we have already executed that code. So what I'm going to do is I'm going to actually execute, or I'm going to send it this file. And this file exists on GitHub. Let me show you what that file looks like. Here it is. And in this process builder that I'm going to be sending, we're going to again call bash, and we are going to curl an existing file, a data binary file, which is the etc password, from that Lambda instance, and we're going to send that back to my ngrok. So we're going to execute this remote Lambda. It's going to send this etc password, a sensitive file, back, and we're going to see that on my local machine. So this is what's happening here. If I run that, of course, this is a Lambda running in serverless, and I am passing it a Spring Boot application, which is kicking up a server, which I love the way that we send a server to a serverless environment. But as soon as this runs, I'll run it a couple of times afterwards as well. We get an internal server error back. Why? Because, well, there's exceptions that obviously aren't being handled and things like that. We're not getting a good response back. But we don't care about that as an attacker. What we care is that we get this response back. And what this response is doing is sending us the etc password of that Lambda machine. Okay? And this is just using plain Jackson in Spring. For some reason, there's a lot of users on this machine. But yeah, this is now where we can see the vulnerabilities that exist, and very, very fixable vulnerabilities, because the latest version of Jackson, it doesn't have known vulnerabilities in it. So we can upgrade, and we can use the later versions which have the fixed code in. Okay, how am I doing? 10 minutes. I'll talk a little bit about what we can now do to fix some of these. The solution. What is the solution to this? Well, there are three things, just like DevOps. Anyone who's done digital transformation, if you've talked to people who are in the C-levels, which is what they call adopting DevOps and things like that, they will look at three things if they've done it successfully. One is the culture, one is the team. The next one is the process, how you alter your processes to deal with the changes. And then, of course, the tooling that you need to support you. And unless you do every single one of these, you are less likely to succeed in your transformation. So from a team point of view, it's about breaking down the silos, pulling people together, okay, encouraging that communication, that discussion, and wanting to adopt. It's a big mindset change, wanting to adopt this new focus. Once everyone's on board, then you won't get people who are still working in a previous way. Process is the second, and this is more about how you can add your testing, how you can add your fixing as part of your process. How can you add your remediation? How do you escalate issues when issues come up? How do you recover from issues when you have them? The process needs to change in order for you to reactively change how you do software delivery. And the third one, of course, tooling, is to really automate as much as we can outside so that we don't do manual things. And also, in talking about that, we don't want to slow developers down. We don't want to slow this pipeline down as traditional security testing has done, because it happens all at once. So what we need to do is we need to encourage the tools to sit in our existing process. And process, we don't want to add process for process sake. We want to get people to add security testing into their existing tools and processes. So, let's talk about how we can add this kind of flow now into your pipeline. So what can you practically change at work? As a developer, we live half of our lives in our IDEs. Okay? So what we need to be able to do is actually run software testing. And I'm going to show you how Snyk does this, but obviously, of course, there are other tools that you can do this for. Now, when we think about, as a developer, running software running tests or writing code in our IDE here, what we can do is add plugins. And plugins can automatically test what we're doing. So at the very, very first stage, we can see these are the vulnerabilities I have, or as I'm adding something else to my POM, oh, look, this has a vulnerability. I've just tested it. Let me work out what my suggested upgrade is. In this case, 2.3.28. I can click on that, and I can upgrade this now to 2.3.28. Okay, so from a developer point of view, we shouldn't shy away from looking at what our dependencies are doing. If you don't have the integration, many different tools will also have CLI versions. So you can just, as and when you update your applications, you can use your CLI versions, which will in this case, inspect the dependencies that you've pulled down, test against known databases, which can provide you with where the vulnerabilities are, and provide you with remediation advice as well. So from a developer, we can fix these issues ourselves. We don't need to leave this till too late. And then what we can do is, when we do want to push to a production environment, when we do want to push to a code repository, one thing we can do, if I go back here to the pull request which we created, there are, of course, many different tools that will allow you to test every single pull request you create, whether it's one that is automatically created by another tool here, or if it's one that you have created, a functional pull request. You need to make sure that you are not regressing. So you are not adding any new vulnerabilities in third-party dependencies to that code. And if you can check it at this level, then you're checking it across the team, because this isn't just set for a user, it's set for everyone who wants to send code to that repository. And then when you go into a CI environment, there are plenty of tools, again, that will test your code at a CI. So as soon as you've built your application, what you might want to do is have either use the integrated tooling with Jenkins or TeamCity or something like that, or do something which will monitor, or do something that will allow you to work out, create a snapshot, create a baseline, and make sure you don't regress past that baseline. And as soon as you get new issues that didn't exist in previous snapshots, what will happen is you have the option then of breaking the job, breaking that pipeline. Okay, so that you're getting notified and you are actually causing breaks at that point to stop pushing to production, because something new has happened and it needs either your attention or it needs someone from a security team to look at it and make a decision. But you get that early view. And one of the other things that I wanted to discuss just before I'm out of time is what happens if, once you've pushed stuff into production, the other thing that you can do is actually monitor those environments. So, for example, in the case here that we talked about, that we showed, once I imported that GitHub project, what we're now going to do is monitor daily. And every single time either a new vulnerability that wasn't there before in our system is found, you'll get a new pull request. As and when new fixes are available that weren't there before, you will get a new pull request. Okay? So this is about monitoring and making sure we don't regress even in our production. And as I mentioned, all of this is actually entirely free for use today with Snyk. Okay, I have 4 minutes left, and I think I can just about squeeze in one more hack. Okay, this hack we're now going to do in 4 minutes and 22 seconds is a cross-site scripting. And this is a cross-site scripting hack in the marked, is it this one? This one. Cross-site scripting in marked. Marked is what allowed us to perform, to show the bold, right? It's markdown support. So it's cross-site scripting. How do you think we can perform cross-site scripting here? Shout out. Script? Like script tags? Okay. What do you want to put in the script? Alert. What do you want to put in your alert? 1, right? Let's be really, really original here. So if I run that, bang. Okay, we get caught. And we get caught because it's recognizing we are doing cross-site scripting. This isn't going to work because it's sanitizing on the way in and the way out. By the way, this isn't the default. The default is to actually break. But we have added in the app.js, I think it is, or something like that. We have added sanitization to be true for marked. Otherwise, that might have actually worked. How else can we do it? Think Markdown. What can we do in Markdown that will allow us to pass URLs? Links. Right, so let's do a link. HTTP. I won't do HTTPS because I can't do that for Devoxx for some reason. Devoxx Poland. Devoxx.pl. Okay, this is what a link looks like. No, actually, that is absolutely not what a link looks like. That's what a link looks like, and I can go to the Devoxx website. But what else could we do here? Let's do a bad link. Anyone know? JavaScript, did someone say? What about if we do something like that? Let's make this a little bit bigger. Okay, so we're going to run some JavaScript. Who thinks that's going to work? Oh, a few people now. Oh, it doesn't. It's still sanitizing. It's still there, but it's sanitizing. And the reason is it doesn't like this colon, and it doesn't like this bracket. Any ideas? Encode. So we're going to do HTTP encoding in 1 minute 50. I'm going to do you know what the encoding is? This is a hard one. 58 for a colon, and 41 for a closed bracket, and 40 for an open bracket. Right, this has got to be it. Who thinks this is going to work? Less people than originally. I think everyone's becoming a little bit more pessimistic now, huh? No, damn, we've lost our bracket as well. Now, the way we are going to hack this is because marked is actually a pretty good language, a pretty good library for doing sanitization. It recognizes this is still a colon, and it's going to turn it into a colon. But what we're going to do is we're going to allow the browser to give us a little helping hand here. And what we're going to do is I'm going to type this there. As a result, these 4 characters are no longer a colon, okay? And we've got this here, which is going to do nothing. But this is going to now pass the sanitization because we are not putting a colon in. And as a result, marked is going to be happy with that. But the browser is going to look at this and it's going to go, oh, look, that almost looks like a semicolon. Let me help you out here. I'll replace those 4 characters with a semicolon. And as a result, we get our bad link. And as a result, I can do one. And if I wanted to now, I can get the document, and I can get your cookie, and I can send your cookie to my horrible server, which is probably running on my mother-in-law's AWS account or something like that, right? So from this point of view, this is an interesting vulnerability, because this vulnerability exists between two places, between the marked and between the browser. Yet it was a vulnerability that was added in marked, and that's exactly my time up. So thank you very much for attending.